Hello, I am Carl Boettiger, and I am here to talk today about teaching ecological forecasting. This is based on a course that I held this past spring at UC Berkeley. So I wanted to begin with a few words about the pedagogy of this course. So we know about 4 things concretely about how people learn. First, that learning is an active process. Second, that learning builds upon prior knowledge. Third, that it's necessary to think of learning as a social activity. All learning occurs in a social context. And last, that learning is most effective when it is taught in an authentic context. Students know why they're learning, what they're learning, and feel like they'll be able to use it in their own world. So our course plan is simply to apply this to forecasting. We work in small teams, because learning is social, to build forecasts for a real world challenge based on prior knowledge of the students in the course. So I have found that teams work best when students have comparable rather than complementary backgrounds. This lets them learn together and share knowledge instead of dividing tasks. I'll also note that teaming takes time. Teams go through phases, and the longer people have working together, the more effective they'll eventually become working as a team. So this doesn't happen overnight. So we kept the same teams throughout the length of the course. So nuts and bolts, our course is basically 4 different components. Core R knowledge using the Tidyverse library and working through the R for Data Science book. This is a fantastic pedagogically informed approach to teaching R in a conceptually unified way. Similarly, we are going to rely primarily on the Fable forecasting toolbox and the associated forecasting textbook, particularly for students that have no prior knowledge in building their own forecasts or statistical models. We will be using GitHub for all of the materials in the R Markdown format primarily. Students will learn both of those, and communication primarily through Slack and Zoom, because of course this semester was entirely online. One of the lessons we learned in this process was the importance of streamlining good abstractions. So allowing students to focus on the forecasting and not focus on some of the technical details that often get in the way. For instance, working within the RStudio interface on a remote server, so students would not have to worry about running out of memory when they needed to work with large databases. We also set up a shared Neon store database and took care of the downloading of all of the raw data from Neon, so students could connect to that immediately and not sit there waiting for things to load. Utilizing automation whenever possible. So many of the kind of abstract tasks that need to be performed can easily be scripted. And so the Neon Forecast toolbox helped a lot with some of these steps. This similar pattern is seen in both the implementations of the Tidyverse suite, which focuses students around the abstraction of a data frame, thinking of all data in this structure. And that similar paradigm is built into most of the Fable suite. Throughout our semester, we had 5 separate teams, 1 for each of the 5 challenges, team size of about 2 to 5 students. We had a huge range of backgrounds from a senior undergraduate student, mostly new first years in the PhD program, and a postdoc. Some of the students were highly experienced or senior PhD students, and some are quite new to R, and they spanned a range of majors or backgrounds coming into the class as well. We began with a twice-weekly meeting schedule as a whole course, but we quickly transitioned into meeting separately as individual teams. This allowed teams to get to know each other better and allowed me to focus on the different strengths within each of the different individual teams. Asynchronous collaboration would happen over GitHub and Slack, and synchronous collaboration over Zoom, unfortunately, given the pandemic situation. In the end, all students were able to demonstrate a GitHub-based workflow, data manipulation in R, and generate and submit a forecast. So those were our goals. Happy to talk more in any questions. Thank you and goodbye.